Type J thermocouples are considered non-incendive devices. Because they do not produce a spark or flame that could ignite a flammable atmosphere, they are suitable for use in certain hazardous locations. The associated field wiring connected to Type J thermocouples is also considered non-incendive, provided it meets certain requirements. These requirements are primarily focused on ensuring that the wiring is protected from physical damage and that there is a means of preventing the accumulation of flammable vapors and liquids around the wiring. This is typically achieved by installing the wiring in a conduit or other suitable enclosure. Because Type J thermocouples and their field wiring are non-incendive devices, the applicable section of the National Electrical Code, or NEC, is 501.4b3. This section specifically addresses non-incendive field wiring and equipment installed in Class 1, Division 2 locations. According to 501.4b3, non-incendive field wiring and equipment shall be permitted to be installed in Class 1, Division 2 locations if the field wiring is installed in a raceway, enclosed cable, or other approved means and is sealed against the entry of dust, vapors, or gases. Therefore, compliance with 501.4b3 involves several key considerations. Firstly, the field wiring must be installed in a raceway, enclosed cable, or other approved means. This provides a physical barrier to protect the wiring from damage and also helps to contain any potential sparks or arcs that might occur. Secondly, the wiring and its enclosure must be sealed against the entry of dust, vapors, or gases. This is crucial to prevent the accumulation of flammable substances that could be ignited by a spark or hot surface. Sealing can be achieved through various methods, such as using sealing fittings, cable glands, or other approved sealing techniques. Complying with 501.4b3 involves properly installing Type J thermocouples and their field wiring in a Class 1, Division 2, Group E area. Since the Type J thermocouples and their field wiring are considered non-incendive devices, compliance with 501.3b6 is not necessary. This section of the NEC applies to intrinsically safe apparatus and wiring, which is a different type of protection method. By adhering to the requirements of 501.4b3, proper installation in the specified hazardous location is ensured. The key aspects of proper installation include, firstly, selecting appropriate wiring and cabling that are suitable for use in hazardous locations. This may involve using cables with specific insulation and jacketing materials that are resistant to chemicals and abrasion. Secondly, installing the wiring in a raceway, enclosed cable, or other approved means. This provides physical protection and helps to contain any potential sparks or arcs. Thirdly, sealing the wiring and its enclosure against the entry of dust, vapors, or gases. This is essential to prevent the accumulation of flammable substances. Fourthly, ensuring that all connections and terminations are made properly and securely. These connections can create a potential source of sparks or hotspots. Fifthly, grounding the equipment and wiring in accordance with the NEC requirements. Proper grounding helps to prevent the buildup of static electricity and provides a path for fault currents to flow safely to ground. Finally, inspecting and testing the installation to verify that it meets all applicable requirements. This may involve performing insulation resistance tests, continuity tests, and other tests to ensure that the wiring is properly installed and functioning correctly. In summary, Type J thermocouples are considered non-incendive devices. When installing them and their associated field wiring in a Class 1, Division 2, Group B area, compliance with NEC Section 501.4b3 is required. This involves installing the wiring in a raceway, enclosed cable, or other approved means and sealing it against the entry of dust, vapors, or gases. By following these requirements, you can ensure that the installation is safe and compliant with the NEC. To further elaborate on the specific requirements for wiring in hazardous locations, it's essential to understand the different types of wiring methods that are permitted. These methods are designed to provide varying degrees of protection against the hazards associated with flammable gases, vapors, and dusts. Firstly, rigid metal conduit, or RMC, is a heavy-duty wiring method that provides excellent physical protection and is suitable for use in many hazardous locations. RMC is typically made of steel or aluminum and is threaded to allow for secure connections. Secondly, intermediate metal conduit, or IMC, is a lighter weight alternative to RMC that still provides good physical protection. IMC is also threaded and can be used in many of the same applications as RMC. Thirdly, electrical metallic tubing, or IMT, is a thin-walled conduit that is typically used in dry, indoor locations. EMT is not threaded and is connected using fittings that are either compression type or set screw type. EMT is generally not permitted in hazardous locations unless it is installed with special fittings that provide a seal against the entry of flammable substances. Fourthly, flexible metal conduit, or FMC, is a flexible wiring method that is often used to connect equipment that is subject to vibration or movement. FMC is typically made of steel or aluminum and is available in both liquid-tight and non-liquid-tight versions. The liquid-tight version is suitable for use in wet locations and can also be used in some hazardous locations if it is installed with appropriate fittings. Fifthly, cable is another common wiring method that is used in both residential and industrial applications. There are many different types of cable available, each with its own specific properties and applications. Some types of cable that are commonly used in hazardous locations include mineral insulated, or MI cable, and armored cable, or AC. MI cable is a type of cable that consists of copper conductors insulated with a mineral compound, such as magnesium oxide, and enclosed in a copper or stainless steel sheath. MI cable is extremely durable and is resistant to heat, moisture, and chemicals. It is often used in high-temperature applications and in areas where there is a risk of explosion. AC cable is a type of cable that consists of insulated conductors enclosed in a flexible metal armor. AC cable provides good physical protection and is relatively easy to install. It is often used in dry, indoor locations. When selecting a wiring method for use in a hazardous location, it is important to consider the specific requirements of the location and the type of equipment that will be connected. It is also important to consult the NEC and any other applicable codes and standards to ensure that the installation meets all applicable requirements. In addition to selecting an appropriate wiring method, it is also important to ensure that all fittings and accessories used in the installation are approved for use in hazardous locations. This includes fittings such as conduit bodies, couplings, connectors, and sealing fittings. Sealing fittings are used to prevent the passage of flammable gases, vapors, or dust through the conduit system. They are typically installed at the boundary between a hazardous location and a non-hazardous location, or at the point where a conduit enters an enclosure that contains electrical equipment. Sealing fittings are available in a variety of types and sizes, and it is important to select a fitting that is appropriate for the specific application. Some common types of sealing fittings include explosion-proof sealing fittings and intrinsically safe sealing fittings. Explosion-proof sealing fittings are designed to contain an explosion within the fitting and prevent it from propagating to the surrounding atmosphere. Intrinsically safe sealing fittings are designed to limit the amount of energy that can be released in the hazardous location, thereby preventing an ignition. When installing sealing fittings, it is important to follow the manufacturer's instructions carefully to ensure that the fitting is properly installed and will provide the required level of protection. It is also important to inspect sealing fittings regularly to ensure that they are in good condition and have not been damaged. In addition to the requirements for wiring and sealing, there are also specific requirements for the type of equipment that can be installed in hazardous locations. Electrical equipment that is installed in a hazardous location must be designed and approved for use in that location. This typically means that the equipment must be explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain an explosion within the enclosure and prevent it from propagating to the surrounding atmosphere. Intrinsically safe equipment is designed to limit the amount of energy that can be released in the hazardous location, thereby preventing an ignition. When selecting electrical equipment for use in a hazardous location, it is important to consider the specific requirements of the location and the type of equipment that will be used. It is also important to consult the NEC and any other applicable codes and standards to ensure that the equipment meets all applicable requirements. Furthermore, proper grounding and bonding are crucial for safety in hazardous locations. Grounding provides a path for fault currents to flow safely to ground, while bonding ensures that all metal parts of the electrical system are at the same potential. This helps to prevent the buildup of static electricity, which can be a source of ignition in hazardous locations. Grounding and bonding must be performed in accordance with the NEC and any other applicable codes and standards. In conclusion, installing electrical equipment in hazardous locations requires careful planning and attention to detail. It is important to understand the specific requirements of the location and to select wiring methods, fittings, and equipment that are approved for use in that location. It is also important to follow all applicable codes and standards and to ensure that the installation is properly grounded and bonded. By following these guidelines, you can help to ensure that the installation is safe and compliant with all applicable regulations. Additional considerations for ensuring safety when using Type J thermocouples and associated wiring in Class 1 Division 2 Group B areas include regular inspections and maintenance. Schedule routine checks of wiring, connections, and sealing fittings to identify and address any signs of wear, damage, or corrosion. Implement a preventative maintenance program to ensure the long-term reliability and safety of the installation. Personnel training is paramount. Provide comprehensive training to all personnel involved in the installation, operation, and maintenance of electrical equipment in hazardous locations. Ensure that personnel are knowledgeable about the specific hazards associated with Class 1 Division 2 Group B areas and the proper procedures for working safely in these environments. Emergency shutdown procedures must be clearly defined and regularly practiced. Establish and communicate clear emergency shutdown procedures for situations such as leaks, spills, or equipment malfunctioned. Conduct drills to ensure that personnel are familiar with these procedures and can respond effectively in an emergency. Furthermore, utilize appropriate personal protective equipment, or PPE. Require personnel to wear appropriate PPE, such as flame-resistant clothing, safety glasses, and gloves when working in hazardous locations. Conduct a hazard assessment to determine the specific PPE requirements for each task. Lastly, maintain accurate documentation and records. Keep detailed records of all installations, inspections, maintenance activities, and training programs. This documentation can be valuable for troubleshooting, auditing, and demonstrating compliance with applicable codes and standards. It is also important to remember that safety is an ongoing process, not a one-time event. By continuously monitoring and improving safety practices, you can help to create a safer working environment for everyone.